All right, so we've got a file to download for today. The file is called productlist.xlsm. Our topic for today is debugging and error handling. So let's first talk just conceptually about the different kinds of errors you might encounter because you treat them really differently. All errors are not created equal. Probably the worst kind of error in one sense is just a syntax error. It means you have typed something that is so bad that the interpreter has no idea what you're talking about. It's looking at what you're trying, and the interpreter in VBA tries to figure out what you mean, even if you didn't say what you meant. But if you've done something that it can't even figure out what you're talking about, it's just the code can't execute. It has no idea what you're doing, and it's going to give up, right? And so you'll see those. Let me just go ahead and open up our little file here and get into VBA. We'll just see a syntax error, Alt 11. Didn't really expect to see an error. Are you getting an error when you open this one? You must have typed something when I wasn't looking. Anyway, there's a syntax error. How provident. There's a syntax error already here in the code. I must have actually planned that. So we look at this, the line turns red, and immediately you go, there's something wrong. Now, for most of you, when you type a syntax error, you hit enter, and what happens? A pop-up button, a dialog box comes up. And it says, do you want some help? And the first couple of times you thought, I could really use some help on this. You click the button that said, yeah, I'll take some help. And then you realized that was no help. And then you quit clicking that button. So if you're like me and you think, you know what, I'm glad to know there's an error there, I'll figure it out, but don't want help, then you can do this to keep that dialog box from popping up. Just come to Tools, go to Options, and uncheck the Auto Syntax Check box. The line will still go red, but you won't get that dialog box that shows up. Oh, so what is the problem with my line? Do you see what the problem is? Yeah, I have misspelled until. So it's so nice. It told me, hey, there's an error somewhere on this line. That's really helpful, especially when someone types as poorly as I do. That's a capital I. That should be okay. And then we can fix the error and then move on. So you might be tempted to think that any syntax error is going to show in with a red line, but that's not true for all of them. Sub test, because here's also a syntax error. If active sheet dot name equals sheet one. Active sheet dot equals sheet one. Then debug.print, hello. Do I have a syntax error here? Any syntax error showing? What's this? Some of you are nodding. What's the error? Yeah, you got to have an end if. Now, can you make an if statement without an end if? Yes. If you put the line that the statement you're going to execute conditionally up here on the same line as the then. But as soon as you say, no, this is going to come on the next line, you've got to have an end if, and you might have an else and an else if and so forth. But so why don't we get a visual cue that there's a syntax error here? There's no line to turn red. That's the problem, right? We're missing a line. There's nothing to turn red here. And so you can have syntax errors that you don't really get the help for. But then, of course, when you try to run it, it'll say, ooh, there's some problem. Now here, this is kind of one of the problems with the error messages. Block if without an end if. So that's pretty good. But let me do this. Let me put a for loop around this. Dim x as an integer for x equals 1 to 5. Next. Ooh. Now, have I fixed my syntax error yet? No, totally not fixed, but let's see what the error message says now. Oh yeah, I do have syntax error, NEXT. Certainly haven't fixed the other one and introduced new ones altogether. Oh yeah, this one is a great error message. What does that say? Next without a for. It found the word next and it's saying, I was expecting the word for sometime before this. And it's not there, but wait a minute. I mean, how do you feel about that error message? Next without a for. How do you like that error message? Is that an error message that makes you happy? What's the problem with that error message? There is a for. You can see it. It's right there. So why does it come back and say there's a next without a for? Yeah, it's because what it's saying is, listen, I'm right in the middle of processing an if statement. I can have a for statement inside an if statement. I can have a for statement outside of an if statement, but I can't have one that's kind of intermixed. And so what it's saying is, it's saying, listen, I'm in the middle of an if here. If I'm going to have a next, there's got to be a for inside this if along with it. And so, boy, the error messages sometimes aren't that great. And that's, so that's kind of one of the problems that that we just have to deal with. Syntax errors, at least there's some help about where they're happening. So it at least tells us here, the problem's right around here somewhere. It could be a little further away if the code's more complex, but that's syntax error. So that's one category of error, syntax error. You've typed something that the interpreter just can't figure out what to do. Got to be able to understand it to be able to start to execute it. Okay, second type of error then is called a runtime error. A runtime error is an error that is syntactically is okay. The syntax is fine. But when your code tries to execute it, when the interpreter tries to execute it, I mean, it figures out what you told it to do. What you told it to do makes sense. But when it tries to actually accomplish it, it's unable to do it. It's not that it can't figure out what to do. It's just like you told it to do something that at the moment doesn't work. So here's an example. I'm going to leave this one. I'll fix this one and then we'll move, go on to a different example. And if, okay. So why don't we call this one syntax error. Okay, next one, let's call runtime error. So runtime error says, oh, this is an error that's we can compile. The interpreter understands what you've told it is something it understands. It may not be what you meant to tell it, but it's something that it understands. You've told it something it understands. But when it comes time to actually do it, it's unable to accomplish it. Okay, so why don't we just activate a particular sheet? We don't need X, we don't need debug, we don't need any next. We're just going to say particular sheet activate. Worksheets, sheet one, worksheet sheet one dot activate. Do I have a worksheet named sheet one? Let me give myself a worksheet named sheet one. There's a worksheet named sheet one. And so I think that code is going to execute just fine. Let's give it a shot. Yeah, works great. So there's proof the code works. That is code that it can figure out what I'm telling it to do. There's no syntax problem here. The syntax is completely correct. But what happens if my user is like, we don't need that sheet, delete it. I didn't like that sheet anyway. Now, when we go to run this, have we changed the syntax? Still syntactically valid. Right? We're still telling the interpreter to do something. And now when it tries to run this, we get runtime error number 9, subscript out of range. It's not a great error message. The subscript is actually, let me give you that error. See, I've got 1, 2. I don't have a sheet number 3. So when I run this, I get the error subscript out of range. If I hit debug, it'll tell me right where that line is. Here's the line where that problem is. That really is a subscript out of range. What's the valid range for the subscript, the number that identifies my sheets? 1 to 2. I've got 2 sheets. They can be 1 and 2, but I've given it a subscript. That number is the subscript. I've given it a subscript of 3, and it's saying no can do. Even though there's no subscript involved here, it's logically the same thing. Like you're trying to refer to something in this collection that doesn't exist. So it ends up being the same error message. So for syntax errors, you have no option but to eradicate them. You've got to get rid of them. The code can't even run. For runtime errors, we have 2 options. 1, we can prevent the error from happening. Or 2, we can notice when the error happens and then say, you know what, if this error happens, let's do something different with it. And so we'll do a different example to kind of show that. But that's we have 2 options for runtime errors. The third class of error is a logic error. Logic errors are the hardest to track down. And the reason is, as far as the interpreter is concerned, no problem. You told it to do something, it could figure out what you meant to do. It does what you told it to do, and it's able to complete it without any trouble, but it doesn't produce what you were hoping it would produce. In this case, the error is where? It's in your mind. Like you've told it to do something, but you think you've told it to do something, then you really told it to, you think you told it to do something different than you really told it to do. And so these are the ones that are really difficult to track down. And so that's the reason. So that's why we have tools called debugging tools, is to be able to help us track down these logic errors, which can be difficult to find. So let's go ahead and get some experience then with these different things. Any then questions on these three types of errors? Because we treat them all differently. Okay, what do we have here? We already have a loop here involved. We've corrected the syntax error. Let's process products. Let's just take a look at our worksheet and see what we've got going on here. So this is some data that I collected off of a website in the early 2000s. It was like a online outdoor retailer. They're long since out of business. But you know, there's a price. Prices probably would cost a lot more right now if you wanted a wood duck squealer, whatever that is, $12.99. What is wood duck squealer anyway? Made of silicon injection molded polycarbonate, produces the full range of calls of a wood duck, sitting or flying. Anyway, so this is product data. Now, and we're going to use this particular data set when we start talking about user forms. Like if you think about, trying to update the product information here, and boy, I'm really interested in updating this one product, and it's taking up a tiny part of the screen, and the rest of the stuff on the screen is not relevant to me at the moment. So I'd like to be able to create something that allows you to kind of give that one record a lot more prominence. That's a user form. We're going to use this data for that exercise, but I want to get us kind of a step in the right direction for there. So what I'd like to do is I'd like to be able to take some of these categories that we have here. Well, category is one of them. Department, there's only like 4 departments. There's a few more manufacturers, and there's not that many categories, but I would like to have some kind of a list of just what those are. So if I were doing this by hand, then I'd probably use like remove duplicates, like copy that, take it somewhere else, paste it, remove duplicates, and so forth. But I want to take you through an example of working through building these lists on a new sheet. In fact, we're going to have a new sheet over here called lists, but we're not going to make it by hand. We're going to have our code make it. So the idea here is I'd like to be able to create some code that can look at a particular column on this worksheet and then build a list of unique values on the next worksheet. So on a worksheet called list. So I want it to be able to say, hey, we'll make a list called category, and it will have the unique values for category. We'll make a list called department. It'll have the unique values for department. The reason that I'm doing this separately instead of just doing remove duplicates is because we're going to get new values come in here. And so when someone adds a new manufacturer, we want to be able to say, oh, you added a new product. We want to see if this manufacturer is already in our data set. If it is, great, we'll just use it. If it's not, we want to be able to add it to the list. So we want this list to be able to be dynamic and grow as we add new information to it. And so let's go ahead and see how we might do that. Okay, so right now we are going through and we are printing whatever is in column 6. What's in column 6? 1, 2, 3, 4, 5, 6. That's the name. Okay, so it's printing the name. Let's do this. Let's come back to department. And what I want to do is I want to have it print off just every single department. So I'm going to change column 6 over here to maybe instead of column 6, I'll actually I can put, a letter in for cells. So I'll put capital C in there. So when I run this, it should print off all of my departments. Printing the row, I'm printing row column 1, the product ID, and then I'm printing that. Okay, so I'm going to get I'll get the row number, product ID, and then the department. So there's a bunch of there's too many for me to be able to scroll because there's like 800 or so products, and I only get 200 lines in the immediate window. So, but we can see that we're getting that information. So step one is I would like to now create a sub procedure that will just allow me to add to a list. So the list doesn't even exist yet. Let me create a sub procedure here that's just called add to list. And I'm going to send two things. I'm going to send the list name that I want to add. And so in this case, we're going to take in a parameter called list name, and we're going to take a value. LIST name and value. So when I'm plugging in, when I'm processing this row right here, I want to send a list name of department and hunting. If there's no hunting value, first of all, if there's no list called department, I want to create the list for department. If when I look at that list, there's no value for hunting, I want to add it for hunting. But if there is a value for hunting, mission accomplished. The value is already in the list. I want to have to add it again. Okay, so that's where we're headed here. So that once we process all this data, sending the department information, I will have the list of the unique departments there on my list table. So let's start off by declaring an object variable to refer to the sheet. So dim s as a worksheet. Now let's set s equal to, out of all the worksheets, the one named lists. Syntactically, that looks great. The problem with this is that there is no sheet called list. So this should be a runtime error. So let me go ahead and we'll call that from here. So we're going to call add to list. And I'm going to pass it then rather than putting this into the loop just now, I'm going to create a sub procedure that's just for testing. So I'm going to call this my Acme sub runner. Just want it to be alphabetically small so that it is the first one. So when I'm down here and I try to run this, I can no longer just press F5 to run this because it has parameters. It'll say, I don't know what you want to run, but you can't run this just directly. So with this being alphabetically small, that will be the top one showing up. I hit F5, it'll say, oh, I can just hit F5, enter to run it. There's no other magic behind its name except that I want it to show at the top of my list. And so here, I'm just going to run just one line so I can simplify the debugging process here. So I'm going to call add to list. I am going to pass it in the word department. Ultimately, we'll be reading that off the worksheet that we're building the list for. And I'll pass it in a value of hunting. Now, when I run this, I'm expecting this line to fail because it's trying to activate a sheet that does not exist. That'll be a runtime error. Subscript out of range, runtime error. Now, let's take step one. So step one to deal with this runtime error would be, let's just prevent it from happening. So how can we prevent it from happening? Any thoughts? How can we, like make sure that error doesn't happen, the runtime error doesn't happen? How can we check to see if the error is gonna happen and then prevent it from happening? Yeah, go ahead.
You can just check if that worksheet exists, and if it doesn't, you create worksheet.
That's right. We could say, before we try to select it, let's check to see if it exists. Okay, so that's our first approach. It would be really great if there's a way just to say to our like the workbook collection, does this worksheet exist? And I don't think there's a way to do that. So let's just create a function to do that really quickly for us. It's going to be pretty simple. Function sheet exists. I'm going to pass it a sheet name. And it's going to return a true or false value. I'm going to reset my code. That's just fine. Let me dim S as a worksheet. And we'll do a for each loop for each S in worksheets. next statement. So whatever's inside this loop is going to be executed once for every worksheet, and S is going to get bound on to the worksheet as it goes. So the first time through this loop, S is going to be the product sheet. The second time through the loop, S is going to refer to the promos sheet. Just show me how comfortable you are with this, just the structure that we have right here. This is one of the harder loops. So 5 is, I totally got it. Something less than 5 is, I'm not quite there. Everyone who's voting is 5. Okay. So now I'm just going to say, listen, if S.name is equal to that, whatever name got passed in, the sheet exists. I do want to make sure that the case doesn't matter for sheet names. So let me just lowercase both sides of this. So I'm going to look at the lowercase version of the sheet name and see if that is equal to the lowercase version of this, of what was passed in that I'm looking for. If that's the case, if those are equal to each other, the sheet exists. The sheet exists. So I'm going to say sheet exists equals true. And then I'm out of here. Exit function. There's no reason for me to keep looking. I'm not going to find another sheet with that name because it's a constraint in Excel. I can't have 2 sheets with the same name. Case, notwithstanding. So exit function, and I'm done. So now, so here's one approach. So we're anticipating that this line could cause an error. Let's check to see if the condition that would cause the error exists. And if so, let's deal with it before we get there. So here's how we might do that. If sheet exists, list. Actually, we want to do something if it doesn't exist. So I'm going to just use the not here. So remember, so this if statement is going to execute if whatever's between the if and the then evaluates to true. If this evaluates to true, the sheet does exist, and I want the code to execute when it doesn't exist. So if not sheet exists, or I could say if sheet exists equals false. And that's probably a little more comfortable way for you to see it at this point in your programming career. So if sheet exists equals false, the sheet doesn't exist, then we're going to do something. What are we going to do? Worksheets. .add. What are we going to add? Worksheets.add. What's that? Oh yeah, work sheets.add. Now, when we create a worksheet, it is going to not only create the worksheet, but it's going to return a reference to the worksheet. This next thing I'm going to do here is going to look really strange, but it's totally legal. This is going to evaluate to the sheet that just got created. And so I'm going to call add, and then I'm going to say .name equals. I'm going to create it and name it all in the same line. So if there is no sheet called lists, make a sheet and call it lists. So if there is a sheet called list, great, move on. We're okay with that. So now if I run this, some function not defined, sheet exists. Oh, I missed my underscore. Then it created a sheet called lists. There it is, excellent. If it already exists, I'll run it again. No error, goes through just fine. So that is always an option when you have a runtime error, is to just adjust your code so that the condition that causes the runtime error, you notice it when it's happening and your code anticipates it. And that's probably the right way to do this one. But this is a simple example. I'm going to show you an alternate approach. So, here is, the comment this out. By the way, if you want to get the tool that lets you comment a whole block of code at once, on your toolbar, you can come up here to View Toolbars, and it's on the Editing toolbar. So I'm going to bring up my Editing toolbar and then just park it up here next to my other one. I got plenty of room for it. And these two allow you to comment and then uncomment a block. So I'm going to come here and say, this is fix the runtime error by anticipating it, or by checking, fix the runtime error by adjusting the code to prevent the error from happening. Okay, now our other approach then is to notice that the error happens. Here's the other approach. Notice the error, the runtime error happening, and adapt. That's this approach here. Remember that the Visual Basic Interpreter has been in every version of Excel. There was one for Excel 2008 for Mac, it didn't have it. But other than that, every version of Excel that has shipped since 1995. Maybe some other Mac versions that didn't have it. And almost every day it goes without being used. We told you this sad story about the interpreter who hopes to get used every time Excel opens, and almost every time it doesn't. At the end of the day, the interpreter says, maybe tomorrow my user will use it. So the point here then is that when this interpreter encounters something that it can't do, it is more than happy to say for you to give it directions. Listen, if you come across something that you can't do, I've told you to do something that you can't do, don't give up. I'll give you something else to do. And the interpreter's like, great, I'll be glad to do anything, as long as I'm being useful to you, master. Very subservient piece of program. And so what we're going to say is listen, if you encounter an error, I'm going to put a statement here that says, if you encounter an error after this point, don't give up, just go and do something else. And so here's how we do it. We're going to say on error. We're saying, listen, in the event of an error, if an error happens, and there are several different things I can do here. I'm going to tell it, resume next. Yes. On error, resume next. This is my favorite way to handle an error in VBA. But it's really dangerous if you use it too broadly. On error, resume next says this. Listen, interpreter, if you get to a line of code that you can't execute, skip it and move on. Now, presumably, you put the line of code there because it was important in the first place. So, by the way, if I was just to put this statement at the beginning of any function, I have just converted every runtime error into a logic error. Because this will this now gives me no indication. If I get to a line that it can't run, it'll skip it and move on. If that has an error, skip it and move on. So nice that you've gotten rid of your runtime errors, but you've converted them into something that's much harder to deal with, logic errors. But what we're going to do is we're going to use this sparingly, and we're going to use it right around the code that we think is likely to trigger an error. And then we're going to check and see if it did trigger an error. So here's the line that I'm thinking is going to trigger the error. So I'm going to say, hey, if you get an error, just keep on moving. And now I'm going to check to see if there was an error. So let me introduce you right now, to some of our debugging tools. So one, we've already used kind of extensively, stop. So stop just says it's a breakpoint written in code. It says when you get to this part of the code, just stop right here and we're going to suspend things. Let me show you how we do that. If we do this, if error.number equals 9, then debug.print error 9. Okay, so far we've seen how to write in our experience, we've seen how to write a breakpoint in code by writing the word stop. You don't actually have to write the word stop. There's another way to do it. And that is you can click right here on the little gray margin off to the left on the line that you want to stop on. That will give you a little red dot and turn the whole line red. At some point, most of you have done that by accident. And when you did that, you went, oh my gosh, what have I done? You clicked on it again and it went away and you went, ooh. That's a breakpoint. That does the same thing as stop, but it says just before you run this line, just stop. So it takes me into break mode, yellow line and everything, but I just don't have to write the word stop. I can just say on this line, stop. And the important thing here is that it stops before it executes this line. Now, I'm in debug mode now, which means my sub-procedure is still in memory. All the variables allocated for this are still in memory. Any objects are still in memory, including a special object called ERR, E-R-R. So let me just, there's a function, I don't think we've used this yet, type name. You can ask for what kind any expression is. So ERR is, it's an object called it's an error object. I can ask what type S is. And right now, it tells me S is a worksheet. So I can, type name will tell me what kind of, what kind of thing am I asking about? So this thing called error then is an object, and it's specifically wired to be able to do this kind of error trapping that we're doing here. So ERR, I'm going to print ERR, you say dot, and then it's got properties and methods. Well, there's a property called number, and that will tell me the number of the error. And right now there's error number 0. When the error number is 0, that means there's no error. When that error object has an error number of 0, no error has been triggered. Now, this didn't trigger an error. Why not? Because the sheet exists. So let me go back and make the conditions that will cause the error. I'm going to go delete my sheet. And then let me stop my code and run it again. Now I'm going to ask for the error number. And now it's error number 9. This is error number 9, subscript out of range. In fact, I can also refer to not just the number, but the description here as well. Description, cap lock off. And it tells me the same message. I get the same information. I have access to the same information that was displayed up to the user when the runtime error just interrupted the execution of the code. So now, what we've done here, now up here, what we did was we said, listen, we're going to check to see if the sheet doesn't exist. And if it doesn't exist, we're going to add it. Now what we're doing here is we're saying, listen, just try to reference the sheet and then check to see if that was an error. If it was an error, and especially if it's error number 9, we know exactly what the error was. If it's any other error number besides 9, I'm not sure we know what the error, I'm not sure we know what to do. But if it's error number 9, we know exactly what to do. What do? We're just going to add the sheet. So then, in fact, I'll do the same thing. Worksheets.add list. In fact, I'll probably do it a little differently here. I'm going to set S equal to adding the worksheet and then say S's name. Because what here, I'm actually trying to bind S onto that worksheet. If that succeeded, great, S is bound onto it. If it didn't, I now need to make it and bind S onto it and make sure it has the right name. And then I'm done. Now, if I had some other error, still that's going to be an issue for me. But if it's error number 9, which is the one I anticipate, I've dealt with it. Let's just go ahead and get the simple part of this going now. And have I fixed my problem? I think now I've fixed the problem, but I've got another problem to deal with. So let me just run this and we'll see if this now builds the sheet for us. Yeah, still builds the sheet, no error. But what's the danger at this point? I'm going to activate, I'm going to put another line that's going to cause an error down here. Now I'm going to set S equal to the sheet called list 2. Is there any sheet called list 2? So what do we expect is going to happen when we run this code? You might expect there to be an error, but there's not an error. And why is there no error? Because I told it, if there's an error, skip it and move on. And so anytime I use this on error resume next, I'm going to be very diligent to make sure that I have turned that off. I've said, listen, thank you for letting me anticipate an error might happen in this block. If an error happens after this point of time, just go back to normal error handling. In other words, show the error and interrupt the code the way you normally would. And the way you do that is really strange. Here's how you do it. Well, before you do it, we got to go back to how the basic language was originally envisioned. In the early days of BASIC, like not Visual Basic, but just BASIC, you would number your lines. Like you would actually say, I'm going to write a statement here. This is line number 1. You would write 1 space, you'd write the statement. And then you want another line, 2, you'd write the statement. So you would number the lines. And then if you wanted to go to a different part of your program, you could say, hey, at this point, just go to line number 17. And wherever it was, it would just jump down to line 17. It was terrible. The language was terrible. And what would happen if you decide you want to put a line between 1 and 2? Could you make a line 1.5? Oh, no. You'd have to renumber every line after that. It was a nightmare. But the very first legal line number was line number. Can you guess what it was? Line number. No, it's line number 1 is the first legal line number. And so if you issued the instruction to tell it to go to line number 0, that was an impossible task. And what we're about to do is we're about to tell the interpreter to do something impossible. We're going to tell it, if there's an error, go to line 1. That's exactly how we're going to say it, by the way. So at this point, on error, go to, I'm sorry, we're going to tell it to go to 0. On error, go to 0. By telling it on error, go to 0, it's something that was never, ever possible in the basic language. And it's the way that you tell the interpreter, at this point, resume your normal error handling. Here, I told you, don't worry about an error. I'm going to deal with the error. Here, we're saying, go back to the way you used to do it. And it's a really weird way to do it. That's what we say. We are telling it here to resume normal error handling. So now when I run this, it should throw the error when it gets to this line, because I have re-enabled the default error handling procedure. So this is what's referred to as an error trap. Boy, which approach do you like better? Trapping the error or checking to see if the error is going to happen and preventing it from happening? Who says prevent the error from happening in the first place? Who says no, just trap the error? Oh, wow. Most of you like preventing the error in the first place. I agree. Here's the reason why you might, there's 2 reasons why you might want to trap the error. It may be that you really can't trap the error. It just may be that, based on what's happening, there's no way to check if it's going to fail before it fails. That's possible. But even if you can, sometimes it is so expensive to check to see if it's going to do it, and it's so processor intensive to actually do it. And if you have to check it often, you might say, this code is going to go way faster if instead of just assume that it's going to work. And when it doesn't work, let's take a look, instead of doing this very long process that checks to see if it's going to fail. And so either you might not, it may be impossible to check if it's going to fail, or it might just be a whole lot of work to check to see if it's going to fail. And maybe you're going to say it's going to fail 1 out of 1,000 times that it runs. We don't want to slow everything else down for the 1/10 of 1% of a time that it's going to fail. And so for those 2 reasons, you kind of balance off. Do I write code to check, or do I observe the error happening and then respond to it? Questions here? Yes.
When the code set up currently, did we set S equal to the list worksheet? Did it just skip that and we never ended up? I guess you said it when you.
Yeah, that's right. So the question is, are we actually setting S to it? And the answer is yes. We're trying to set it here. When list doesn't exist, it fails. When it fails, we keep running because we've got the resume next. We'll come in here and I'll say, hey, was it error number 9? And we go, yeah, it was error number 9, the one we expected. So now we're going to bind S onto the newly added worksheet, and then we're going to name it lists. So either way, either we go through this code and this works, so we skip this one, or this fails and we do this one. At the end of this, we've got a worksheet named S, or we've got a worksheet named lists, and it's bound to the variable S. Now, I don't know what else could possibly cause the error to happen besides the sheet just doesn't exist. But it's a little bit dangerous, because if it was something else, I've just suppressed that error without really understanding what it is. So what I'm going to come in here is I'm going to put an else clause in. So if the worksheet is this, we'll come into the else if ELSE, else if error.number is different than 0. Error.number is different from 0. We want to do something different. Because of course, if it's not error, if it's error number 0, if it's error number 0, that means this wasn't an error. So if it's error number 9, no, it's not. If it's different than 0, here. So if it is 0, we're going to skip. We're not going to do either of these blocks if it's 0. But if it's error number 12 or error number 1004, then I need to deal with that. So I've got a couple of things that I could do here. One is I could send myself a text message. We haven't learned how to do that yet, but we're doing that, right? We could do something to notify something, some other error has happened. And could I include which error that is? Yeah, if I could ask the error object, what's the description of the error? What's the number of the error? And I can log that somewhere off of this machine. And kind of depending on the system that I'm writing, if this is for someone else to use, we come across an unexpected error, I'd kind of like to know about that. And then I might, put up some message that says, hey, sorry, this has failed, and contact Professor Allen for a fix. Or I might just say, you know what? If that happens, just go ahead and interrupt it as usual. I didn't anticipate what the error was, but just go ahead and break into the code as normal. So to do that, I almost never do this. Let's see if I remember how to do it. ERR dot, there's a method called raise. And that will just say, just raise this error. And I'm going to give it a number and a source. I don't even know what the source is for. Let's go ahead and raise that number and we'll give it the description. So the number I'm going to give is ERR dot number. Not quite sure what source is for, but I'll also give it ERR dot description. Wait, is there actually a source object? ERR dot source. Oh yeah, whatever source is, I'm just going to pass the source along. ERR dot description. Because I don't really know how to trigger any other kind of error, let me say here we're looking for error number 90. So now when we have an error number 9, we'll skip that one and we'll hit this other trap. So I've gotten rid of my sheet. So this will cause an error now. We're not going to catch it with here, so we should be able to catch it with here, and we should see that raise the same error. So I'll run that now. And there we're getting exactly the same error because we said, listen, it's not an error that we anticipated. And so let's just go ahead and raise it in the normal way. I'm going to put this back to 9 now. So now we'll handle error number 9. And if it's anything else, it'll raise. And I'm not sure, I really can't think of anything that would cause it to happen. But anytime I've suppressed the error, I should really make sure that I've dealt with that error properly. I look specifically at the values that I want to, the errors I'm handling. Otherwise, I'm raising up the flag. Questions? How comfortable are you with writing? This is called an error trap. That's not a VBA term, that's a programming term, it's an error trap. How comfortable are you with the idea of an error trap? 0 to 5. 4, 4, 3.5, 3. Okay, it's new stuff. And it's not, we're not covering this in the first week of class because it's not simple stuff. All right. Any questions on the idea of an error trap? Let me show you another kind of error trap that our book actually spends a little more time on. And this is the one that I find of most utility, but I do want to show you the other one. So if sheet exists, let's go ahead and put an error trap in here, just so you can see the other kind. So on error, go to. Now, in the early days of BASIC, you made line numbers that you went to. It wasn't long of doing that they said, you know what, it'd be really great if you didn't have to use line numbers. We don't want to number our lines of code. It was a nightmare. There were special programs just for renumbering your programs. And so they came up with this idea called a label. We can just put a label somewhere in our code and we can just jump to that location. Folks, BASIC, including Visual Basic, allows you to kind of just like arbitrarily jump to different points of your code using labels. This is something you want to use very sparingly. And this kind of an error trap is one of the places you say, this is an okay way to do this. So what we're saying is that on error, go to, and I'm going to create a label, ERR handler, HANDLR. So this is saying, up here we said, listen, if there was an error, skip it and move on. Here we're saying if there's an error, go to a particular place and move on from there. So stop what you're doing, go somewhere else. It has to be somewhere inside the same procedure. You can't tell it to jump to a different procedure. got to be a different location in this procedure. And we are going to give it, we're going to give a line this name. This is called a label. I'm going to come down here right to the very end of the function. And I'm going to put in that label with a colon. And that says this is a named location in this procedure. And so debug.print error happened. And ERR description. Okay, let me just put a line in here that's going to cause an error. Dim S has a worksheet, and we declare the variable. I'm going to declare the variable outside of the error trap. You can never get a runtime error on a variable declaration. The reason is variable declaration is not actually an executable line. Variable declaration says, you're telling the interpreter, I need some memory to be able to run this procedure. And the way that the interpreter handles it, it says, oh, you want to run this procedure? It looks through the whole procedure. Before it starts running it, it looks through the whole procedure. It finds all the dim statements. And it says, we need this memory allocated, and it allocates that memory before it starts to run. So if you've got a problem with your dim statement, it will happen. It'll happen as a compile error, as a syntax error. Actually, I guess there's probably another class of error called the compile time error that the syntax is okay. But let's not split that hair. So it's never a problem to have your dim statements outside of an error trap because you cannot throw a runtime error with a dim. So now let me do something with this. That's going to be an error set S equal to worksheet 100. Like there's only 2 worksheets. So I try to set to worksheet number 100. It's going to be a problem. And so you'll see then that I'm not going to have any error be shown because of this. And you'll see it now just jump straight to here and keep executing the code. So worksheet exists. I got to find a way to trigger this. So let me make another. Let me just trigger worksheet exists up here. I'm going to comment out my other line, and then here we will just trigger that. So debug.print sheet exists lists. Right now, there's no sheet called lists, and so it will call this. It's going to try to return false, but it's going to have an error before it does, because this line is going to cause an error. So let's run that and just see what happens. So error happened, subscript out of range. So that's exactly what we expected. Oh, still returns false. Why does it return false? It's Boolean function. You know, if it doesn't have an error, like if it continues running, it's going to return either true or false. I never told it to return true, so it returns false. So let's introduce then this breakpoint. Let me go ahead and put a breakpoint on this line right here. So when I run my code, it's going to come to this point and it's going to stop. We're going to introduce some other debugging tools here at this point. So I'm going to go ahead and run this again. So we're now stopped right here. Now I can tell my interpreter to go one line at a time so I can watch what it does. And that's on my debug menu. There's a thing called step into, step over, and step out. We're going to see these right now. So what does step into do? Well, actually, step into, step over, and step out all do exactly the same thing. Unless you're calling a sub-procedure or you are inside a sub-procedure that was called. If I'm calling a sub-procedure, in fact, let's back up just a bit. Let me put the breakpoint not there. Let me put it up here where I'm calling this. Put a breakpoint right here. So just before I run this, we're going to come into break mode. Now, if I come in here and say debug, let me do step over first. Step over is the most confusing one. Because if I said, you're on this line right here, you're ready to run this line. If you step over that line, what do you expect is going to happen? Is it going to run that line? Or is it just going to select? I mean, if you're walking down the street and you saw something on the street that you did not want to step into, you're going to step over it. Would you experience that thing you did not want to step into? No, you'd skip it. And it's exactly the opposite here. Step over says, go ahead and run that line, but don't step. Don't go one line at a time through it. Instead, just do the whole thing and bring it back to the next line. If I do step over, it's going to do that whole sub procedure. Printed here and printed false. And that was kind of already in there. So let me do that again. By the way, you can drag your current statement indicator back. I'm going to go ahead and step over that. Debug step over, which is Shift F8 here. And yeah, it went and did it, but it didn't go one line at a time. Now that is different from step into. Step into says, yeah, we're still going to do the whole thing, but we're doing it one line at a time. I'm actually going to go one line at a time through the procedure that I'm calling. It's a really handy distinction because you might say, listen, I need to go line by line to see what's happening here, but calling that sub procedure, I'm not concerned about what's happening in that sub procedure, just do the whole thing. So step over is almost always what I do. And then occasionally, I didn't want to go in that sub procedure, so we'll step into. And that's just regular old F8 or debug step into. And so now that's going to come in. I'll just use F8 from here. That's going to go in through this one line at a time. Okay, so here's going to be the error. We're going to see it now jump from here. When I try to execute this line with F8, it's going to jump right to the error handler. So I can see that. So that's a really valuable thing about break mode is I can go a line at a time and see where it's going on. Because when I have a logic error, my code is not executing through the same path that I think it is. And so being able to step line at a time and seeing where it's going is really, really helpful. So it's coming, right to that line and then moving on. So I will F8 and step out. By the way, if I press F8, like my insertion point is here, F5 will just run this, but F8 will step through this as well. I'm going to come in here and I'm going to step into this one and I'm going to go, oh man, I didn't mean to step into this function. I don't want to have to step, this function is almost 1,000 lines long. I don't want to step through this whole thing. That's what step out does. So if I look at debug and say step out just says, finish running this procedure, but I don't want to see it one step at a time. Just finish it and then take me back to wherever this procedure was called from. So Control Shift F8 or step out will just finish running that and take it back to where it was called. So if you're just on a line, you're not inside a sub procedure, you are not calling a sub procedure, the steps do the same thing. I'm trying to think of how you could have code that's not in a sub procedure. Yeah, it's going to be in some sub procedure somewhere. So step into will be the same unless you're calling a sub procedure. Step out will always yank you out of to the next level up from wherever your call stack, wherever you are on the call stack. Call stack is when you call a function, it loads that function up. And if from that function, you call another function, it loads that one, and then it loads another one. So that's the call stack is just like how, if you've got multiple functions called from each other, they're kept track of in this thing called the call stack. So when you step out, you go to the next function in the call stack. Okay, questions on stepping? All right, let's take a look at another tool for debugging, which is called the immediate window. We've used debug.print a lot to put stuff up to the immediate window. So, but I'm going to take the error out of here. Yeah. Okay, so I'm getting rid of this error. I'll leave the error handler. Oh no, one more thing I want to show in the error handler. Let me go back to having this error. Actually, I want to take this out. Okay, so now I no longer have the line that's going to cause the error. Did I? Oh, I did the wrong one. That's the dim. This is the one I want to get rid of. And maybe I'll just comment this out. Okay, so I'm no longer going to have the line that causes this error. But I want you to see what happens when I run my sub procedure. I'm just going to run the whole thing through. Why am I getting error happened? Is an error happening? Go ahead with this comment or question. Yeah, I told it debug.print. This label doesn't end my sub procedure. It's just a mark of the line in the code. And so when I go through this without an error, it goes all the way through here. It gets to this error handler and goes, oh, this is just the mark for this line. That's great. And it just moves on. So it prints error happened. It doesn't print the description because there is no description. There's no error right now. There's no description to print. And so when I do this kind of an error handler right before this label that I have at the end of my procedure, I put in exit sub. So if I made it this far, if I made it this far, if I get to this line, then I got here without an error and I'm just done. Get me out of here. So this is another really common approach to handling errors. I favor the one where I very tightly scope the error, the code around the error, the suspect code. And I think when it's for your own use, that's probably the best way. When you're writing code like for other people to use and you need more sophisticated ways to deal with that error, then this might be a better approach. But for individual use, tightly scoped around the lines that will possibly throw the error, I think is the better approach. Okay, questions here? All right, to look at some of our other error, debugging tools, let's go ahead and build that function to add a list. Do we start with this? Yeah, add to list. So we're going to come back to add to list. I'm going to comment out our comment to go to debug or to the error that we had in sheet exists and re-enable this add to list. All right, so we're getting down here. So if we get to this point and get rid of this error here as well. So if we get to this point here, I'm just going to put a little comment that says what we know. What do we know here? There is a sheet called list. And the variable s is attached to it. Great. So now what I want to do is I want to find out if this list, if the name of the list that we're trying to add an item to, in this case, it's going to be a list called department. I want to see if that exists on the sheet already. So to do that, we're going to do find. We've seen an example of find before, but I wouldn't expect you to remember it. So let me come in here and say dim found cell as a range. Then I'm going to set found cell, equal to, and now on my S sheet, I want to look at the first row because the idea here is that on that sheet, the name of the list is going to be what's on the first row. I just want to look at the first row and see if the name of my list exists there already. So s.rows dot number 1 dot find. What am I looking for? I'm looking for the name of my list, which is list name. And I want to find a complete match, XLWHOL. The ones I'm skipping over here are like search from the active cell, and I forget what else, but this is going to look for a complete match on that first row. So if it finds it, S will be bound onto it. If not, it won't. In fact, if not, S at this point, found cell at this point is going to be, it's going to equal the variable nothing or the object nothing. So I'm going to say if found cell is nothing, then we'll do something. Otherwise, we will. And if we'll have an else in here as well. Okay, so if it's not here, right? That list name's not, if the list name is not there on row 1, I want to put it on row 1. So I'm going to say this s dot cells, row number 1, and I want to go to the very last column on this sheet. What's the last column? It's like 16,000 something. I can never remember where it is. And truth is, who knows? It might make a new version of Excel that has even more columns. If I've got more than 16,000 lists, I think I've got other problems to worry about. But let me go ahead and just ask it what the last column is. So I want to go to the very last column, the very last column, and then I want to come back to the beginning of that. I want to find the first cell that's not used there. So I'm going to say s dot columns dot count That'll be the very last column number. So this will be like, right, this is going to, let's see, if I had a list called sheet, if I had a sheet called lists, then what I have so far on that code is referring to that cell right there. Right, you can see that. I'm looking at all the cells in the worksheet, row 1, which column? However many columns there are. Last column, that's that one right there. From there, I just want to move back till I bump into some data. So I will say dot end XL to left. And that would be, let me put some data in here. They're great list names. So I'm all the way here and I do like control left arrow, that puts me on the cell. Oof, I want to be one more to the, I want to be one more to the right. I want to be right there. So from this location, yikes. From this location, I want to just move over 1. So dot offset. How many rows? 0 rows and 1 column. And that is the column that I'm after. So let me ask for the column. That'll be the column I'm going to end up writing all of my data to for this run of the procedure. So I better have a variable to receive that. So here's my dim found cell as ranged, dim call as an integer. So call is going to equal that. So we are finding the place that we want to write the value in that header. And then I just want to actually write that value there. So call is going to equal that. So S dot cells, row number 1, column number call, dot value is equal to my column name, my list name. So we said, hey, this list doesn't exist yet. We're going to put that list here onto this sheet. Now, that's going to happen if we don't find the cell. What do we want to do if we did find the list name on row 1? We just want to set our column to where we found it. So found cell will be that cell in column 1. So we just want that to be found cell dot column. So we're either going to add a new header at the end of our row to put our data in, or it's already there and we're going to know that's the column that we're going to write to. Ooh, I don't know if we're going to even finish this example in the next 5 minutes. I think we will. At this point, we know the column to write to. We now know the column. Now we got to find out if the value we're trying to write is already in this column, right? Because ultimately what we're trying to do is we are trying to put in, what was it, department? Yeah, we're trying to put department like here, and then we want to put hunting here. And then if we have hunting on other ones, we want to skip it. But if we get to outdoor, we want to put outdoor. If we get to apparel, we want to put apparel and so forth. So let's find the row. And this is going to be really similar to finding the column. In fact, so similar, I'm going to copy this whole block and bring it down. So now, instead of looking in row 1, I'm going to look on a particular column. Which column am I going to look in? Call, like the column I just found. And I'm going to find not the list name, but I'm going to look for the value. Is value what's passed in here? Yeah, value. So at this point, if it finds it, it finds it. Otherwise, it'll be set to nothing. So the same thing. If it's nothing, it means it didn't find it. Now we're ready to just put this on the end of the list. So same logic, but we're working with the column instead of the row. So we'll need ourselves a variable for that called row. Actually, I don't think we need a variable for that. We can just write it to it. Okay, so let's just do this. We were going to say s dot, so we didn't find it. Cells, which row are we looking for? We're going to have to find out the row. So I think this is going to be pretty complex. I think this is okay. So s dot cells, we want row number. Let's get the column in first, then we'll come back for the row. So our column is the call that we found before. Now, what we want to do is we want to get to the very last row. We want to find the last row of data and go one cell down from there. It's tempting to say start at the top and go down, but if I don't have anything yet, if I start at the top and there's nothing below it on that one cell, it'll go to the very bottom of the worksheet. So I'm going to go to the bottom and come up. So we'll do a similar thing here. We're going to say s.rows.count. Column number column. From there, we will do nxl up. And then we'll offset, from there, we will offset one row, 0 columns. And we're just going to put the value right there. So the value that got passed in is going to get written right there. If we did find the cell, there's nothing for us to do. The list is there, the value is already there. That's all we're trying to do, make sure the value is there on the list. So there should be no need for an else clause here. And we don't need this one either. So if it finds it, nothing to do. If it doesn't find it, we need to add it to the list. We didn't see as much more debugging as I wanted to. So let's at least, we're going to run this once, and I'm going to introduce you to this last idea, and that is the immediate, not the immediate window, it's the locals window. So view locals. Locals window will be interesting when I'm in break mode. So I've got this break right here. Let me go ahead and run my code and get to this breakpoint. Hopefully we get there without error. Okay. The locals window, I'm gonna zoom in so you can see it because it's tiny on this screen. It says, all right, you've got some things that are module, dealing with your module, and then you've got some other things that now are available. Here's list name and value, and we can see all of our variables that we have declared here. We see what their values are. As we go through line by line, we'll see them change. So if I step now with F8, well, we're out of time, but if we saw, if these values were changing by the code, we would see these values changing as they go. So if we do a debug.print, it just shows you what's in the variable at that time. But if you've got your locals window open, it will actually, you see the variables and you'll see them change as they go. There's a few other tools out there for debugging, but these are the main ones that are going to be most useful. The book covers a few more, and probably a good idea to review them. All right, the test begins tomorrow. Don't take the test tomorrow. There's going to be lots of snow. So put it off for a while. Remember, whatever day, I think the schedule tells you, like the last day, it's $5 to take it. Any questions? All right, thanks for coming. No class tomorrow. I'll post the video, and I'll see you on Monday. Class dismissed. Questions? Okay, actually, let me just see if this actually looks like it did. I want to run this one. Well, I got a call. And my department is doing hunting. There's one of those. Something's not quite right, but. Okay.
So I submitted it once, and it told me these are valid ISBNs.
They are.
Yeah, this was, it's 13 XMP.
Oh, you're ignoring anything that's not in there. Good ignores the X. You should
Okay,
ignore the X.
okay. So just get rid of it. So the X only happens when it's a 10.
And it's ISBN 7. No.
Okay.
Yes, he does.
Thank you.
Yeah. So you saw this, you saw that again? There's an example of that.
Yeah, but all
Yeah, they're similar.
they're pretty.
Yeah.
They're not
They're
like
not
once
complex.
a day, there's like 5 different sub procedures. And then like kind of having to go through them. Is it gonna be like that? Or you're calling different procedures? You know what I'm saying? So
Yeah,
like.
yeah, yeah. I think we're gonna call different substitutes on the final exam. I'm pretty sure we don't do it on the midterm.
So they're gonna be relatively. Moderate.
They're gonna be relatively simple, meaning there's not a lot of code there. Simple doesn't mean easy, right? But you have to go through and you're gonna say, okay, what does this line do? What does this line do? They're gonna be short. They're generally short. That's not true for the finals. I will be a little bit more involved, but you're gonna have, another 6 weeks.
How would we prepare for the final?
Same thing. But you will be more experienced.
That's good. Thank you.
Yeah.
Quick question for you. I was working on the ISBN validator and I got it most of the way there.
You stopped recording. We want to immortalize your question, for future students.
Yep.
We don't want to give the answers.